Hello students, this is SD Sir from the Temple of Excellence, Vidhyaashram Pre-University College, Mysore. There is a famous quote which says, "Curiosity is the mother of all inventions." Aren't you all curious as to what we have in store in this session? Yes, today I will be discussing a very beautiful topic called as conductivity. I give a small assignment where I make you all derive Ohm's law, and finally, very important, we shall discuss something called as limitations of Ohm's law. Now, before I could actually move on with the class, let's recall two important definitions we studied yesterday. The first one, what we call as resistance. ಯಾವ ರೀತಿ ಡಿಫೈನ್ ಮಾಡಿದ್ವಿ resistance na? We told it is some type of opposition. Who is opposing? Conductor. For what? Flow of electric current. And we wrote R is V divided by I. And a very important definition, resistivity. What was resistivity? It was again nothing but resistance. But it was the resistance offered by a conductor whose length was 1 meter, unit length. And area of cross section 1 meter square. Its SI unit was ohm meter. With these things in mind, today we will start discussing a very important topic, something what we call as conductivity. ಪರೀಕ್ಷೆನಲ್ಲಿ 5 ಅಂಕಗಳಿಗೆ arrive at the alternative form of Ohm's law ಅಂತ ಕೇಳ್ತಾರೆ. Ohm's law ಓದಿದ್ವಲ್ವಾ? ಏನು ಹೇಳಿದ್ವಿ? Current which flows through any conductor should be directly proportional to the potential difference, provided physical conditions do not change. V equals I into R. Adana mathematical form ant karadve. Today I shall be discussing the concept of conductivity, and through this concept I will be arriving at the alternative form of Ohm's law. Now, before going to conductivity, let us try to understand something called conductance. My dear friends, you studied resistance. Resistance, opposition to the flow of current. Conductance, allowing the flow of current. Aste vyathyasa. If resistance is the opposition to the flow of current, its reciprocal is called conductance, allowing the flow of current. Alternating current alli admittance antlu ottira. That concept I'll take there. Now, what was the SI unit of resistance? Beautifully we wrote ohm with this symbol. What was conductance? It was the reciprocal of resistance. Therefore, the unit for conductance is mho with an inverted ohm, or specifically for conductance, we follow a unit what we call as Siemens. ನೋಡಿ, ಒಂದಕ್ಕೊಂದು ಎಷ್ಟು ಚೆನ್ನಾಗಿ ರಿಲೇಷನ್ ಬಿಲ್ಡ್ ಆಗಿದೆ. ರೆಸಿಸ್ಟೆನ್ಸ್ SI unit is ohm. Conductance reciprocal of resistance. Therefore, the unit becomes the other way, mho with this symbol. But the commonly followed symbol or unit for conductance is Siemens. But now, friends, I am discussing something called conductivity. Conductance ಅಲ್ಲ, ಕಂಡಕ್ಟೆನ್ಸ್ ಅಂದ್ರೆ ಏನು ಅಂತ ತಿಳ್ಕೊಂಡ್ವಿ, ರೆಸಿಪ್ರೋಕಲ್ ಆಫ್ ರೆಸಿಸ್ಟೆನ್ಸ್. ಹಾಗಿದ್ಮೇಲೆ ವಾಟ್ ಈಸ್ ಕಂಡಕ್ಟಿವಿಟಿ? ಇಟ್ ಈಸ್ ದ ರೆಸಿಪ್ರೋಕಲ್ ಆಫ್ ರೆಸಿಸ್ಟಿವಿಟಿ. ಕಂಡಕ್ಟಿವಿಟಿ, ರೆಸಿಸ್ಟಿವಿಟಿ. Conductance, resistance. So, dear friends, what was conductivity? It is the reciprocal of resistivity. Specific resistance ಅಂತಲೂ ಹೇಳಿದ್ವಿ. ಯಾತಕ್ಕೆ ರೆಸಿಸ್ಟಿವಿಟಿನ ಸ್ಪೆಸಿಫಿಕ್ ರೆಸಿಸ್ಟೆನ್ಸ್ ಅಂತ ಕರಿತೀವಿ? It is the resistance offered by a conductor whose length is specifically 1 meter and area is specifically 1 meter square. Therefore, that resistance is called specific resistance. So, heli nodana, conductivity andreno? It is the reciprocal of resistivity. So from my yesterday's session, how did we relate resistance and resistivity? First we told resistance was directly proportional to length and inversely proportional to cross-sectional area. ಹೇಳಿದೆ, Y1 ಅಲ್ಲಿ ಇದನ್ನೆಲ್ಲ ನೀವು ನೆನಪಿಟ್ಕೊಳ್ಬೇಕು. Are directly proportional to the length of the conductor and inversely proportional to area of cross section. Now, from the mathematical form of Ohm's law, we wrote V equals I into R. V is the potential, I is the current, and R is the resistance. Now, relating resistance and resistivity, we wrote R equals rho L divided by A. Baraduvalla idana? Yes, in my previous session, I have related resistance and resistivity as R equals rho L divided by A. ಯಾವ ಸಿಂಬಲ್ ರೆಸಿಸ್ಟಿವಿಟಿನ ಡಿನೋಟ್ ಮಾಡುತ್ತೆ? Rho. Substituting in Ohm's law, V equals I. So instead of R, I write rho L divided by A. Now this is parametrically important. Analyze very carefully here. I have a quantity I divided by A, and that I divided by A is represented by the capital letter J. ಗಮನಿಸಿ ಕೇರ್ಫುಲ್ ಆಗಿ. I instead of R, rho L divided by A. In that expression, the ratio I divided by A is represented by J, a very important term in the study of electric current, where I say J is current density. ಏನು ಕರಿತೀವಿ J na? Current density. And mathematically, it is I divided by A. Numerical solve ಮಾಡಬೇಕಾದ್ರೆ ಈ expression ಬೇಕಾಗುತ್ತೆ. Current density J equals I divided by A. If so, what is the physical meaning of current density? No exaggerations. ಅದೇನು ದೊಡ್ಡ quantum physics ಅಲ್ಲ. Current density means amount of current flowing per unit cross-sectional area ಅಷ್ಟೇ. Current density. ಒಂದು ಕಂಡಕ್ಟರ್ ತಗೊಳ್ಳಿ, ಒಂದು ವೈರ್ ತಗೊಳ್ಳಿ, 1 ಮೀಟರ್ ಸ್ಕ್ವೇರ್ ಏರಿಯಾ ಕನ್ಸಿಡರ್ ಮಾಡಿ, ಯೂನಿಟ್ ಕ್ರಾಸ್ ಸೆಕ್ಷನಲ್ ಏರಿಯಾ. ಆ ಒಂದು ಯೂನಿಟ್ ಕ್ರಾಸ್ ಸೆಕ್ಷನಲ್ ಏರಿಯಾದಲ್ಲಿ ಎಷ್ಟು ಕರೆಂಟ್ ಫ್ಲೋ ಆಗುತ್ತೆ, ದಟ್ ಇಟ್ ಸೆಲ್ಫ್ ಇಸ್ ಕಾಲ್ಡ್ ಕರೆಂಟ್ ಡೆನ್ಸಿಟಿ. ಸೊ ವಾಟ್ ಇಸ್ ಕರೆಂಟ್ ಡೆನ್ಸಿಟಿ, ಮೈ ಫ್ರೆಂಡ್ಸ್? It is the amount of current, magnitude of current which flows per unit cross-sectional area, 1 meter square area of the given conductor. And what is its SI unit? 1 mark question ge relevant ಆಗಿ ಕೇಳಬಹುದು. Current is ampere, area meter square. So ampere meter minus 2. So remember, J, current density, very important factor, is I divided by A, whose SI unit is ampere meter minus 2. So substituting here now, V equals I divided by A, what did I call? J. What remains? Rho, L, and I'm calling this equation 1. So potential in terms of density, current density, V equals J rho L. Now, the moment I have potential, what is the next term I am equating it with? Nothing but electric field, field strength, potential. What is the relationship between them? 101 times I told E is minus dV by dx. ಇದನ್ನು ಪ್ರೂವ್ ಮಾಡಿದೀನಾ? dV by dx ನ ಪೊಟೆನ್ಷಿಯಲ್ ಗ್ರೇಡಿಯಂಟ್ ಅಂತ ಹೇಳಿದ್ನಾ? ಎಸ್. ಸೊ E equals minus dV by dx. So here V is the potential, L is the length of the conductor, so E becomes equal to V divided by L, or V equals E into L, and I call this expression as equation 2. Therefore, if you analyze equation 1, V equals J rho L. Left hand side ಅಲ್ಲಿ ಏನಿದೆ? Potential. Equation 2, V equals E into L. ಮತ್ತು ಪುನಃ ಲೆಫ್ಟ್ ಹ್ಯಾಂಡ್ ಸೈಡ್ ಅಲ್ಲಿ ಏನಿದೆ? Potential. So can I not equate equations 1 and 2? Yes. So E L equals J rho L. Equation 1 and equation 2, the right hand side is equated. Here L and L gets cancelled. So E equals J into rho. My dear friends, I'm trying to arrive at a concept called conductivity. And how did I define conductivity? As a reciprocal of resistivity. Resistivity was rho, and reciprocal of resistivity should be 1 by rho. Somewhere, can I arrange this term to get 1 by rho? So J equals E divided by rho. Beautiful agide nodi. Rearrange ಮಾಡ್ಕೊಂಡಿದ್ದೀನಿ. So J becomes equal to E divided by rho, or J equals 1 by rho into E. ನೋಡಿ 1 by rho ಸಿಕ್ತು ನನಗೆ. What is 1 by rho? Resistivity, the reciprocal. And what was that called? Conductivity. So I say this 1 by rho is equal to sigma, where sigma is called conductivity of the conductor. And this is the alternative form of Ohm's law, where I am representing current density J in terms of conductivity and electric field strength. So J equals sigma into E. Sigma is called the conductivity of the conductor. Now what is its SI unit? Its SI unit is Siemens per meter or mho per meter, and this is the alternative form of Ohm's law. Now, going to my next book work, which is actually an assignment. From the previous concepts, I want you all to arrive at the mathematical form of Ohm's law. Drift velocity expression kottidini. Current in terms of drift velocity is derived. I have explained something called relaxation time. Please to make efforts. I have told hard work has no substitutes. By now you have to pitch into terms that you can derive physical equations. So my book work today is very important, where I want you all to derive the mathematical form of Ohm's law. Now, what was the statement of Ohm's law? ಸ್ವಲ್ಪ recall ಮಾಡಿ ಏನು ಹೇಳಿದ್ವಿ? Current flowing through any conductor should be directly proportional to the potential difference, provided temperature and other physical conditions remain constant. So I made a revolutionary statement there saying the limitation is well established. So very clearly, in detail, I will discuss the limitations of Ohm's law. Limitations andre non-applications, where Ohm's law cannot be valid, where Ohm's law breaks down. Such situations gives me limitations of Ohm's law. The first, please to highlight, Ohm's law holds good for metallic conductors only at moderate temperatures. ಅದು ಸ್ಟೇಟ್ಮೆಂಟ್ ಹೇಳ್ತು. Ohm's law holds good if temperature does not change. Andre, the very validity of the expression voltage becoming proportional to current happens only at moderate temperatures. If temperature is a constant, if the temperature goes on changing, then the establishment of Ohm's law breaks down. Andre, this expression V proportional to I is no more valid. That means deviations occur at low and high temperatures. When I say deviations occur, we deviate from Ohm's law. We deviate from the condition voltage being proportional to current at very low and very high temperatures. See, for example, when you do an experiment where you calculate resistance per unit length of a conductor, it is a practical applicability of Ohm's law. Al ಪ್ರತಿಯೊಂದು ಸತಿ ನಿಮ್ಮ ಮೇಷ್ಟ್ರು ಏನು ಹೇಳ್ತಾರೆ, after every trial, switch off the source for 3 or 4 seconds. Why? To reduce heating effects, to reduce the change in temperature. Why have I reduced the temperature? For the establishment of Ohm's law. So very clearly, my first limitation says that Ohm's law, V being proportional to I, holds good only at moderate temperature. However, it breaks down at low and high temperatures. You cannot establish Ohm's law if there is a variation in temperature. Second one, there is a textual statement which says materials which obey Ohm's law are ohmic devices. ಮತ್ತು ಪುನಃ ಪರೀಕ್ಷೆನಲ್ಲಿ ಕೇಳ್ತಾರೆ 1 ಮಾರ್ಕ್ಗೆ ಗಿವ್ ಎನ್ ಎಕ್ಸಾಂಪಲ್ ಫಾರ್ ಓಮಿಕ್ ಡಿವೈಸ್. ನಿಮ್ಮ ವೈವಾನಲ್ಲಿ ಕೇಳೋ ಚಾನ್ಸ್ಗಳು ಜಾಸ್ತಿ ಇದೆ. ಹಾಗಿದ್ರೆ ವಾಟ್ ಈಸ್ ಅನ್ ಓಮಿಕ್ ಡಿವೈಸ್? I come to understand any material for which Ohm's law is obeyed. Ohmic, the device is obeying Ohm's law. The device is in concurrence with Ohm's law. Such devices are called ohmic devices. For example, they have written resistors, capacitors, voltmeters, ammeters, galvanometers, etc. Here you have a picture of an ammeter and a picture of a voltmeter. Galvanometer. What will a galvanometer do? Detect the presence of current in a circuit. Ammeter, it will measure the amount of current in a circuit. Many a times we get confused and say galvanometer measures current. No, it detects the presence of current, checks the presence of current. Whereas an ammeter measures the strength of the current. And they are all treated to be ohmic devices. ಅಲ್ಲೇನೋ ಮೇಷ್ಟ್ರು ಹೇಳ್ತಿದ್ದಾರೆ, ಈ ಎಲ್ಲ ಡಿವೈಸ್ಗಳನ್ನು ಓಮ್ಸ್ ಲಾನ ಒಬೇ ಮಾಡುತ್ತೆ ಅಂತ. ವೆರಿ ಗುಡ್ ಸ್ಟೂಡೆಂಟ್ಸ್, ಒಬೇಯಿಂಗ್ ಓಮ್ಸ್ ಲಾ. ವಾಟ್ ಈಸ್ ದ ಫಿಸಿಕಲ್ ಮೀನಿಂಗ್ ಆಫ್ ದ್ಯಾಟ್? ವಿಚ್ ಮೀನ್ಸ್ ಟು ಸೇ ದ್ಯಾಟ್ for any such device, the VI characteristic is a straight line passing through the origin. Very important. If any device has to be called as an ohmic device, if something has to obey Ohm's law, V is directly proportional to I, or V by I has to be a constant. Andre, see, voltage along x-axis, current along y-axis. Independent quantity, dependent quantity. Current depends on potential. If the potential is 0, current is 0. Potential apply madlilla, then see, there may be straight charges, negligible current. But steadily speaking, when the potential is 0, current in the conductor is 0. And as you observe here, as potential increases, current also increases linearly. Therefore, we say VI characteristics is a linear graph starting from the origin. What if I have a graph like this? Voltage, this is current, this cannot be accepted. This is not in relevance with Ohm's law. Why? Voltage is 0, actually there is some amount of current which cannot be agreed. So if at all Ohm's law has to be satisfied, the relation V and I is linear, straight line passing through the origin. So, examples for ohmic devices: resistors, capacitors, voltmeters. Now, materials which do not obey Ohm's law are called non-ohmic devices. Now, what is the meaning of being non-ohmic? For example, we say all semiconductors are non-ohmic. Vacuum tubes are non-ohmic, discharge tubes are non-ohmic. What is the meaning? Very clearly, V is not directly proportional to I. For such devices, the linear relationship between potential and current breaks down. Therefore, if you can see, the graph of V versus I is not a linear graph. This is for semiconductors. You see, there is an exponential increase. This is not a linear increase. Again, an exponential graph. So very clearly here, the linear relationship between V and I is disagreed, is broken down. Such devices are called non-ohmic devices. Ohmic devices, the graph between V and I is linear, starting from the origin. For non-ohmic, it is an exponential graph. V proportional to I is not established. And therefore, if you see, the ratio of change in voltage to current for a semiconductor is what you call dynamic resistance. You have heard about resistance, V by I. Here it is R equals delta V by delta I. That is the change in voltage with respect to change in current for a non-ohmic device. The resistance offered by a non-ohmic device is what we call as dynamic resistance. So my dear friends, today we established the alternative form of Ohm's law, conductivity, which was the reciprocal of resistivity, current density, magnitude of current flowing through unit cross-sectional area, J equals rho A, alternative form of Ohm's law. Limitations of Ohm's law. We studied examples for ohmic devices, non-ohmic devices, and I pretty much expect that you do the book work. Please do practice. Please do have hard work. It will lead to success. The next session, we will continue with a device called resistor and its concepts. Thank you.